approach, a different approach of how to design a road. A different approach of how to design a road. We call it extract. Let me remind you that both this road, and this road, we designed by using the cross-section. We went to the cross-sections, and from there, we designed and got the layout. Another approach, which by the way, you can combine the two, is to start from the layout, and from the layout come up back again to the cross-section. So we'll see it in action. This is the road that I'm referring to. Okay, I remember I did it in the beginning. I just created the horizontal alignment. I'm not sure that I have a vertical alignment, so let's see. This is road number, how do I know? I click here, 2, you see? See elements 2 or section 2. So this is road number 2. So I'll go to the vertical alignment. I will go to T1, which is road number 2. Okay, I will see I already have a vertical alignment design here. Good. Okay, so I finished with the horizontal and the vertical alignment of this road. Now I want to design its layout. Now, instead of going from the cross-section, I will design it from the layout itself. I'm doing it in standard AutoCAD. First of all, I will create 2 new layers. One, I will call it my layout road. And the second one is my layout sidewalk. Two new layers. See this one and this one. And the sidewalk, I will do it, give it a little bit also greenish, something like that. And now, of course, I can just draw, or I would use this existing center line to design. See, on the center lines, there are 2 layers. One which is the center line itself, and another one which are the elements of the road. You see, this is one element, and this is another element. So what I do, let me remove the element, so I'll have the center line. Okay, this is the center line. And what I'm going to do with it, I'm going to offset it, let's say 3.65. Oh, offset 3.65. Okay, this one here, this one here. And this one and this one, I would change it to be on layer my layout road, the one that I just created. My layout road. Okay. So what I did, I just created 2 polylines, this one and this one for the road. And I'm doing the same, let's say a sidewalk of 3.5 meters to here, and the 2 shorter one, 2 meters. No, also 3.5 meters. From here to here. Okay, good. And this one, I would change it to my sidewalk. Good. So this is what I designed. I just draw my road. Now let's say, let's see the audience. I don't know. Talia, from which office are you? Tehila. Tehila, from which office are you? Tehila is not helping us. Dor, maybe you can help us. I want to create a parking space here. How much should I enter inside? Do you have any clue, or?
2 meters.
2 meters. Okay. So what I'm doing 2 meter offset from here to here. And I will make my road as the current road layer. And let's say object snap from here to here up till before the junction. Oh. Okay, so what I did a parking space here of 2 meters. So let's just trim it. Okay, and trim again. And again. Okay, so this is what I did. My road start from here, from the junction with 3.65, and then there's a parking space going along like this and go back here. And let's do something similar here, parking space here on this side. So I'll do offset of 2 meters from here to here, and polyline from here to here, and another one from here, sorry, from here to here, and I trim it. So this one, this one, this one, and this one. Fine, let me save it. So far I just use AutoCAD. And I design my road. So again, let's look what we have. We have 3.65 meters starting from here. Then my road is, oh, the trim here didn't go well. Why? Let's do again, trim. It's very important. The trim will be at the end. Okay, and then I did a parking space of 2 meters here. Then before this junction, narrow it down again, and then another parking space here. Okay, this is my design. By the way, I don't have to, but it would be wiser to join it to a single. You know what? Let's leave it like this. The only problem can be if here it's not trimmed. Okay. Now, instead of going to the cross sections, I'm going into something that I call extract. What I'm going to say to the software, look, this is my layout. I'm giving you a typical cross section, and I want you to use the layout to create the road surface, and of course, cross sections and so on. How do I do it? I go to extract. Okay, this is the extract. It's very similar to the cross section. You see, there's a window here, table here, table here. Please listen carefully. First of all, I'm using one template. It asks me, do you have if I have several templates, then I have to create different segments. These are lists of segments. In this case, I have only one segment that goes all along the road from 0 to 486. When, for example, I want to use different segments, if I had, let's say, here, I start a median here, then probably I will have to use one template here, different template here, different template here, and so on. But in this case, it is the same template. So I have only one segment from 0 to 486, which is all along the road. And this is the cross section. I'm starting the same principle, 0, 0. You remember, we did it together. And then I will start from to the right. Now, here the offset is less relevant. The offset is less relevant because the software, I will tell the software to choose the width by these lines, these control lines. So it's less relevant. It's just to give the software some kind of idea. So what I'll do just for this case, 3.65. By the way, I can choose 2 meters. It's not so important, but I will use 3.61. But very important, the side slope. In this case, 2.5. This is the asphalt, but I want you to connect to this same layer that we talked about. Where is it? My layout road. So this segment, which is the asphalt, this 3.65, have to change according to the layer my layout road. It means when I rerun the function, the system will look at right side for this layer, and when the system will encounter this layer, instead of using 3.65, it will change this according to the exact width. If it's 3.65, or in the parking space, it's 3.65 plus 2, so 5.65. Now to the sidewalk, it was 3.5 meters. And let's say the sidewalk has a different slope, 2.5 plus 2.5. What plus 2.5? Let's see it. Right? We're going from here to the road. Right? This is 3.65. From here, I'm going this slope because I want to create some drainage here. But I forgot to put this one. So here, I just use the 15 cm sidewalk like this. Okay? I hope you can follow. But this point, this control point has to stick to look for a layer name, because 3.65 is the optimum. But we know that in the parking space, it got narrow. So let's look for the control layer. My sidewalk. So this control point is looking for this line or this layer. Okay, let me continue. We end up to the right. Now let's do to the left. Minus 3.65, minus 2.5. This is also an asphalt. This is my layout. My layout road, and also sidewalk of 15 cm with, sorry, minus 3.5 and 2.5 going into the road, and this is my layout sidewalk. Okay. Here it is. This is my road. And now I can design my subgrade. So let's say a thickness of 0.5. And here I'm entering 20 cm into the sidewalk. Right from here, 3.6 out plus 20, 3.85. And here I would just go, but instead of 15, I would go, I want to leave 20 cm, so 30 and 0.45, right? And it will be 3.3, 2.5. This is what I did. Okay, instead of going one by one, I just did it like that. It's my decision, it's not important. And the same goes up to the left. Zero, 0.45. I hope you can follow. So this is my typical cross sections. Now in this case, I have only one typical cross section, which I intend to use all over. So I only one segment. If I want to create more segments. Good. Now I want to project it. Create, sorry, not create. Extract. How do I do it? This button. I'm pressing extract to run the function. Okay. Now, what the software is doing now, you see? The software went with my typical cross sections, projected. Here it's 3.65, so vertical. But here it discovered that there's a wider lane to the right. So it make it wider. Here it go back again, and here wider to the left. In fact, if I want to see the results, I can go to cross section and see what happened. Okay, first of all, I see that interpolation is not complete. So what I need to do is to press interpolate, to rebuild all the sections. Remember that interpolation do two things. One, interpolation do two things. One, it goes all along all the cross sections and rebuild them. And if there are empty sections, it's also fill in the data. So there are two functions for interpolation. Interpolation do two things. Again, if there are empty sections, it will do interpolation of them, but it would also go to each section and rebuild it. So like, for example, I stand here and press apply, this is rebuilding, and so on. But what I wanted to show you is what the software did. In section 0, it's easy, 3.65, 3.5. But look here, after 23.5 meters from the beginning, the system identified a change. Where is this 23? I believe that is this point. In this point, the system identified the change. So it digitized a cross section here, although it's not 25 meters there. Actual one is 1.5 meters later. It digitized a section here for the beginning of this, the change, because this section 25 is already wider, right? It's 3 point, sorry, see here what's happened? It's in the middle, it's here. It's already wider. It's not 3.65, it's 10 cm wider. So the software create a demi section here created. So you can see it here, and the same one here, and the same one here. All the breaks, when they start to be breaks in the section, it create in the layout, it created demi sections. What I wanted to show you a few things. First of all, demi sections automatically get a star. A star means that the section exists, but it will not be shown on the layout. By the way, I can do it for every section. For example, if for a certain reason, I don't want to show this section, 0.75, I can go to 0.75, click here, give it a star, and if I will recreate the layout, here, this one will not appear. 1 second to update. So again, the section exists, but it will not appear on my layout. So these are sections with stars. Let me remove these stars. And if I want to see this one, I can see it. I can remove this and remove even this break just for inspection purposes. And do like this. And then all these demi sections will appear. You see this 0.23 and 0.28, and you can see they fall exactly on the break, here and here, in the break point. Any question about this? It's quite complicated, but it's important for you to understand. So if you have questions, just ask me. If there are any questions, this is the time to ask. Don't be shy, because this is quite complicated, but it's important to understand. Either unmute yourself or just write. No, the principle is for you to feel like you are in a classroom, not just. Okay. So it's not just a lecture. It's interaction. Okay. So again, if you have any question, just write it. If you remember, want to ask again. But this is the trick. What else should I know about extract? First of all, this has been created as regular sections. If I want to change them, to do anything, I can do it here. There's no problem. I can do whatever I want here, right? I can just change it here. Another thing that you need to know is that the intermediate sections, this one, the demi sections, by default, the sifted does not take its existing ground level. It does not. Why? It does not do it to save time, to make the system work faster. Obviously, it's yes. Obviously, it saves time, so it does not take it. But the problem starts not in this situation. In the situation where, for example, I want to have a layout. Let me explain. Let me go to the first section. And you see it's closing up like this, because the assumption is that from here I will have some fence and maybe land development. But if I want to end it up with a slope, let's say 1 to 1 to the left, 1 to 1 to the right.
Yeah.
Left and right.
Нелечка, извини, пожалуйста, можно это через час? Я просто в зуме civil card.
Okay. Okay. So what I did, I changed this 1 to 1 and changed this to be 1 to 1. But you remember, this is only in the first section, the rest. No. So we learned what to do. We stand here, we go to this one. If we want to project it all over, stand on it, right click in the mouse, send to all. Same here, right click in the mouse, says sends to all, and the same goes for this, send to, what I'm doing, I'm staying inside, left click, so I would be in editing here, and then I right click in the mouse. Okay, so now this has been sent to all the sections, and so the same I'm doing for this one. Okay. Okay. And this one as well. And to rebuild the sections, interpolate. Sorry, a mistake, interpolate. So all the edges will be reclosed by the new definition. Okay, 1, 2, okay. Everything be closed, but see what happened here. The system doesn't know how to close, so we just do it like this. If I draw the layout, let's see what will happen. See what happened? Here it starts good, but here there's a break here because there's no existing, it's not accurate. The side stick here is not accurate. It does not reflect the reality because the system doesn't have ground level here. So in this case, what I would do, I'll tell the software, get topo data for all sections. So now it will take the existing ground level for all section, including the intermediate, you see, including this one. And of course, I will have to tell the software interpolate to rebuild all these sections. So let's see. Okay, now you see even the intermediate sections. Okay, here there is no side stick. Or build. So if I create the layout now this is quite advanced what I explained, but those of you that use the software might encounter this problem, and this is the solution. You see, now the layout reflecting, the side stick, this line and this line reflect the actual sticking with the ground without the distortion here. And this is a classic question being asked by users. So again, the problem was that we had intermediate cross section like this one, let me mark it as intermediate, and this one that didn't have a ground level, and therefore the system didn't know what to do, so it just gave a template of ground level, and then the width was not accurate. So what I did, I took the topo for all the sections and rebuilt, and that's all the problem. By the way, if you go to extract and you go to options, you see, you can tell the software define sections extract. And if you tell the software, you press here, the software will also take the existing ground level. I hope you got it right. If you have questions, just let me know. If you have questions, let me know. If not, we are going into sewage and drainage design, underground infrastructure. We'll do a break of 5 minutes and we start again. So in 5 minutes, we meet again and we start designing some network, drainage, and sewage here. Okay, so take 5 minutes. Think about questions if you want to ask them. Thank you. Sorry, I was on mute and you couldn't hear me. I will go to the last hour of training and the last lesson, in which I'm going to talk about underground infrastructure. But before going there, if you have questions or you want me to demonstrate anything, this is the time. Anything that you want me to demonstrate, to show, this is the time. Just either speak, unmute yourself, or just write. Okay? If you recall anything, just let me know, because this is the last time opportunity to do so. What I'm going to do now, I'm going to underground infrastructures. I'm going to underground infrastructure. The principle of underground infrastructure is very similar to the one of the roads. It means we start with what we call layout. Instead of horizontal alignment, we call it layout. We continue to the profile and so on and so forth. The main difference is, of course, that the pipeline has its own characteristics, on unique things. Okay, but before doing that, I want to make sure that the road, let's say I will design my pipes. I'll design one pipe that goes here and another pipe that goes here. Now, before doing that, I want to ensure that this road and this road are surfaces. Why? Because I'm gonna take and design according to their surfaces. How do I do that? In the horizontal alignment, when I create the layout, I need to check this one, triangles. You might ask why not check by default. The reason is because that it sometimes in long roads takes a long time. So sometimes we prefer to complete our design and only then create a surface out of it. Triangles. So I have to do this, and I'm doing it first of all for this one. I'm in road number 2, this road. So let's start with this one. You know what? I will, yeah. So I've created a surface out of this road. Okay, this is small road, so it's not a long thing. And I will do also for the main road, this one, road number 1. Triangles. So I have 2 surfaces. I've created 2 surfaces, this surface and this surface. Good. If I go to if I want to design, how do I start? I start with pipelines and with the list, like we did with the roads. I will start with drainage, and the diameter of drainage will be centimeter. You see, I'm checking it. And this is pipe number 1. It would be a drainage pipe. Of course, the profile of the pipeline itself is round as well. So this will be the first one. And then the second one will be also a drainage with round profile. So we'll have one goes like this, and the second one goes like this. Good. And I will start with the layout. So before I start with the layout, I have to draw the layout. For my ease of use, what I'll do it like this. And let me take all the contours, the contours and break lines. Try this and make them dark blue. Okay. And the road itself, oh, there's a lot. And the contour lines, road contours, all the road contours. To here, I'll make them this green. Okay, and the layouts, edge, all the edges, I'll put them green as well. And the data, okay, I want to see the data. Yeah, like this. Okay, just for me, for easier reference. Okay, what is this? Berm. I'll take them and make them green as well. Good. And what is this? This is the slope itself. Incline. Take these 3 inclines and then make them like this. Good. Okay. Now let me start designing my road. My drainage. So I'll create a new layer. I'll call it my drainage. Where is it? My drainage. I'll make it the current. And I will give it this kind, light blue. I give it a light blue. And I will start my drainage, let's say, from this is the beginning of the road, or this is the last one. This is section, yeah, start from here. So one manhole will be here. Okay, let's do up to this point, each 100 meter. Continue to here. Okay, so this is one, and I'll do a polyline, object snap. Where is the vertex? From here. Okay, I'll do from here. Polyline. Here, I'll break it. To here. Here. And that's it. Okay. Here it is. And here I'll do a trim. Okay, and p-edit to join it. This join with this one. Okay, so this is my drainage pipe layout. Okay, I forgot to do one here. It's my mistake. I do break. Say here. Okay, and polyline. Where is the beginning of the road? This is 0, 0. Yeah, from here. So going from this manhole this meter to here. And up to here, 100 meters. To here. Good. So I have two layouts. And edit this one, join, sorry, this one, I will stretch it to the endpoint. Edit this one, join with this one. Good. So I have this polyline and this polyline. These are the two drainage which I have. I'm going to the layout. And the first one which I'm selecting is the main one, right? Pipeline 1. And the second one will be pipeline 2. If I press apply, software already knows that it's a drainage, and that's it. We got two drainage pipelines. So let's start from this one. Let's start from here. Okay. Now in drainage, let's assume that this is not a circle manhole, but it's a rectangle. So let's start from the first one. This is line number 1, right? Line number 1. If I move a little bit to the right, it says, what is the diameter of the pipe, which I've not entered. So the system just did the default. And I've not entered the manhole. So the diameter of the pipe, I'll go to the beginning. I will take all this and I'll tell the software the diameter of the pipe is, let's say, 50 cm. How did I do it? From the beginning to the end and entered 50. The diameter of the manhole, it's not a diameter. It is, I want to do it a square manhole. So I'm entering the size 100/100. Let's see. Here it is. Again, how did I do it? I went to the right. Okay, what I got here, let's see what I got. I got in the table, I got the coordinates of each point like this. Each manhole has a coordinate. It's a point, control point, 1 MN1. It's been created here. You can see it here. All right, actually it sits in a level layer. We call it design points name layer. We can take this layer and make it okay. But we can even freeze it if it's not important to us. But what's more important is that I entered a diameter of 50 cm. The length was 100 meters from the layout. And I also entered the size of the manhole. How do I do it? 100. But by the way, I can do it, for example, like this. You know what? Let's leave it 100. And this specific one, I will change it to 150 by 100. Okay, so it became 150 by 100. How do I do it? Here. See, just change it and everything change here. You know what? Let me freeze this. It's just confusing me. Okay. That's what I want to see. Okay. So this is what I got, the drainage. This is 150 by 100. Manhole number 1, line number 1. The second one, manhole 2, supposed to be 100 on 100. Where is it? Here it is. And so on, so forth. By the way, if I want to create an intermediate, a new manhole along this pipe here in the center, I can just come here between this, right click in the mouse, insert row, tell the software to put it, let's say 50 meter or whatever, 50 meter here, and apply. So, and I apply. The software automatically create a new pipe, a new manhole here, and it gives it a name 1.11. But I see there was a confusion between 1.2. Okay, this was 1.2, and this is 1.2. See? Okay. Yeah, this is supposed to be 1MN2. The mistake, I didn't put it in the right place. 1MN3. So let's restructure it. I see it by this. Okay, now it's okay. So it's a new manhole, but the default was just with nothing. So let's put it also 150 at 100 and pipe diameter 50. Now, since the software didn't know how to call it, it just gave it a name, MN1 and 1.11, because it's intermediate between this one and this one. I can change the name. I can call it 1.1A if I like. So it will become 1.1A. I hope you got it. Nice. And okay, let me stick to this one and then I'll go to the next one. I'm going now to sections, pipelines, sections. See the window. This is not AutoCAD window. This is a designated drawing environment, although we are about to change it in the next version to be fully AutoCAD. But for now, this is one. So first of all, like in the roads, in the profile of the roads, I need to extract the existing ground level. If I press apply, the software digitizes the existing ground level. You see the section is different. Now it's designated for pipes. And it found one intersection, which is this one, which we know already. The intersection is here. So one intersection was found. One intersection was found. Now the sifter for now doesn't have a design, so it just buried 1.5 meters in the ground as default. But this is the existing ground level, and we want to take the road level. By the way, there's a problem here. Now, I don't know what does this mean, why it happened. It's something related to the surface somewhere here. I have two options. One, to go and look for the problem and recreate the surface, or I can stand here. I'm looking at here, station. This is 183. If I go to the existing ground level, scroll down to 183, here it is. You see 133.22, this is 75 meters, when the rest is 73. I would just stand here, right click, delete the row, and apply. That's it, the problem disappeared. So again, the problem is that the surface had the problem. I have two ways to rectify it. One, to go to the surface and try to rectify the surface, but I don't care now. So what I did it much faster. I went and looked for the problem. Like, for example, I want to rectify this one. I think that maybe this is the correct, I don't know, but the last one was abnormal. This, I'm not sure it's abnormal, but let's see. This is at one, I'm looking at here. This is 183.39. Where is it? Here it is, 39. Not exactly 39, 29. Standing on it, right click in the mouse, delete row. Even this one can delete. And I'm sure a little bit flatten this place. This is the method. Okay, I have the existing ground level, but of course I want the roads level. How do I do it? You remember that I created the surface. I took the road and created the surface out of it by the road horizontal alignment triangles. What I'm going to do now, I'm going to the design. And I told the software, get the design, get design data. The software now looks for the surface of the road and automatically digitize it. Let's see. Here it is. This is the surface of the road. So the red is the existing, but I'm more interested in the design surface. So how did I do it? I flipped from existing to design and pressed Get D to go to the design surface. And this is what the software did. Good. So I have existing, I have design, I have two surfaces here. All the data of the surfaces are shown here. For now, I know that there is a, this is the existing design, this is the station, and this is the name of the manholes. I also know the manhole size, 150, 150. And let's start designing. From here, I want to go, so let's look at the table. Let's go from the left to the right. This is the name of the manhole. Remember, manhole 1, the next one was 1.1a, the one with the intermediate, which I've created. Manhole 2, 3, and so on. This is the running distance of the manholes. This is the distances between the manholes. This is the invert level of the manhole. This is the drop. If there's a drop between the entrance and the exit, you put it here. Instead of enter the invert level, I can enter the depth. I can do either this or either this. What if I enter the depth, it will calculate the invert level. If I calculate enter the invert level, it will calculate the depth. I have the slope. Again, slopes, invert level, depth, slopes, and drops, all of them interlink, change while you design. We'll see it in action. This is the pipe diameter, which we already entered to be 50. Wall thickness, I leave it, the wall thickness of the pipe itself. Receptor, invert level, manhole, invert level. Okay, this is in case that we want to create a pop-up. And the manhole invert level is not on the road, but it's above. sorry. The manhole is not in the interval level of the pipe, but maybe it's dropping below. This is the material. This is manhole size. This is the ground level. In this case, is the design ground level. And this is what I meant before. If I want to create a pop of the pipe in roads, of course not, but in open area, usually we put a pop. So how should I design? I'm starting with a depth of 1.5 meters here. Then I can tell the software, look, the depth here is also 1.5 meters. So the software calculates. So when I entered and press enter, the software automatically calculates the invert level and the slope. Let's press apply. Here it is. I started with 1.5 meters here, continue 1.5 meters, and the software calculates that this is 1.6% slope and completed the rest of the information. The height of the manhole and that data. Now I see that it's overwrite, but it's overwrite only because this is not an AutoCAD environment. When I will take it out here, the XF out, it will become okay. And from here, I have two options. I can go by the slope, let's say, or I can go by the depth. So I'll tell the software, you know what, here, it's not 1.5, here it's 1.5, and make a straight slope here. So I skip this manhole, go to the next one and enter 1.5. See what happened. The software automatically shows me that there is a 5.2% slope from here to here and calculate the invert level here. If I click, oh, okay, here it is. How did I do it? I did not enter anything here. I just went to the next one, and then the software calculates the slope. From here, again, I'm doing the same trick. I'm skipping this one and entering a depth of 1.5 meters here. Here it is. And from here, I want to design in a different way. When I say different way, I want to design by the slope. How do I do it? So I'm in here on this one. This is 1.5. And I want to design to 1.6. Actually, not just 1.6. I want it to go up to here. 537 up till here. At the same slope. How do I do it? I'm going to the slope, coloring it for all the sections from here to here, and enter a slope of going down minus also 1.6%. And by pressing enter, the software will calculate the invert level and so on. Here it is. Okay, so this is my design so far. And from here, I want to continue. Actually, I want to continue with the 1.16 all along. Minus 1.6. Good. So this is what I got. I have minus 1.6. By the way, the depth here is already 3 meters. Is what it says. 1.6. Here I'm changing a little bit to 0.39, and from here going and going. This is my drainage. If I'm happy, I'm pressing OK. I can add more details if I want, if it's important for me. And if not, I'm just pressing the XF out And for this entire pipe, and put it and call it section. Pipe section. Okay. I finished with this one. By the way, if I want to see the data on the layout to project it, I go to pipelines layouts, press apply, and now all the invert level and the rest of the data should appear. You see, top level, height, invert level, invert level. Some goes here. The same goes here, and so on and so forth. I hope you got it. Any questions so far? Any questions, please? Any questions? If you want to ask anything, this is the time. If you want me to repeat something, something was unclear, just write or unmute yourself and I will do it. Okay. So let me finish. Let me go to pipe number 2. And the diameter of pipe number 2 will be 30 cm. And the manholes also will be 100 by 1. Okay. Okay. By the way, you see what happened here? The system automatically identified the link between this and put it as a plus. So this is not 2.1, is 1.9 plus. Because this is 1.9 here, so it's 1.9 here. 2.1, this is 2.2, so on and so forth. Any questions? None. Okay. And okay. And here I want to design as well. So, okay, if there's a question, sir, all pipes are straight. Can you change some to curved pipe on the layout? What do you mean curved pipe? If it's a drainage, if you want to break something to be a curve, it cannot be a drainage. I'm not familiar with a drainage with a curve, unless you break it with a manhole. In water supply, it's a different thing. Okay. And there's another, okay, so IFY, the answer is you can do it in water supply, but definitely not in drainage and sewage. There's no such thing, curve. On the, there's another question. Since the unit of system is in meter, why are we using cm? No, it's the system in unit is meter, but the good thing about pipes is that we can use different units for the length and for diameter. Of course, I can put it 0.5, but it's less popular, and the same goes for manholes. Manholes and pipes, usually we show it in more accurate centimeter, or of course, but I can write here 1 on 1. I can do it. But I decided that since although the system of unit for length and height are meters, for the diameter and for the manual size, I decided to be cm. But I could use meter, but it's less popular, of course. Okay, more questions. Okay. Now, go into section and doing the same thing. Apply, and change from existing here to design and get the surface. Okay, so this is the road surface. Again, there's a plunk here. Now, why this is coming? This is probably from the surface. Now, looking at the things, okay, it might be because I'm starting at the junction and here I didn't arrange it. I can leave it like this and later on fix the surface and rebuild it, or I can fix it here, whichever I like. For example, I can go now. Sorry. I'm talking about this. I can leave it like this because it's still in the junction, which was not arranged yet, or I can just go to it. This is after 6.98. So this is the one, just delete it. And it was fixed. Good. Let me continue. Oh, here also a problem in the end of the drainage. There's no enough road. Maybe the drainage is out of the road design. Okay. So I can leave it like this, or I can continue to design, or I can shorten whatever I want. Let's leave it like this. Okay, here, of course, I'm starting with do we have control over each pipe inlet level and outlet inlet elevation? Yes. Okay. If I understand, the question was about whether, for example, this one. Is that correct, Mr. HNCYI? The inlet level here and inlet level here. Okay. For now, I've just used one. Okay. So this is the inlet level. Now, there was a question how to control the difference. Okay, I do it in the drops. I can do it manually, or I can click here. Calculate drops according to slopes inside manholes. Okay, if I want to give it like, I know that I want 2 cm difference, I can just take all this and make 2 cm. But if I want the software to calculate according to the manhole width and to use the same slope inside the manhole width, I'm using this button. I'm clicking in it, here it is, it's calculated. If I will apply, we'll see it here. See? So in this specific, this is station 96, 96 years here, this one, 180. So there's 5 cm drop between here and here. In fact, you will see it here. Sorry, here, 65.91, 65.96. How this is clear. This is something interesting that happened because of what I did. There is a exposure here. It means the depth of the pipe. Okay. If I go to options, you see this? There's a definition of what we call minimum manholes cover, a minimum pipes cover. It means that the software will alert whenever the pipe is exposing more than 50 cm. The cover is not at least 40 cm. So from here to here, the pipe, the difference between here and here is not 40 cm. I can fix it. How do I do it? You know what? Let's change the slope of this one. Let's change the slope of this one. This is 1.6, make it 1%. Let's see. There it is. Okay. I changed it to 1%. So now this is 1% and everything changed accordingly. Other questions, please. Do you want me to repeat something, to show it again? By the way, the slope here is according to the former slope, 1.6, but now it's 1. To recalculate it, I have to remove the drop here. I remove it by deleting. And the delete, and recalculate. And the software asked me, do you want me to rewrite all the drops or just on empty? Actually, I didn't need to do it. If I press yes, it would automatically calculate it. That's it. Now it's okay. It's 2 cm here. Okay. Now I'm going to section 2, and I'm starting from here, right? So the elevation here is the invert level, unless I'm doing a drop, is 69.74. So instead of ending depth, I would just enter 69.74. Okay, the depth is 1.02. It's okay. And from here, I'll go with a slope of, and from here, I'll go with a same slope until this one, till 194, until this one, 92. So from here, the software here is 1.5 meter. So the software automatically calculates on the invert level and the slope, 2.45, 36. Okay, let's change it to 35, so it will be the same, like this. Good. And from here up till here, same slope. So depth here is 1.5 meter, and calculate. And the software will go like this. Okay. So this is my pipe. This is my pipe. This is my drainage. I'm happy with it. I go to layout and rectify, apply. I will see all the invert level and everything that I've designed here. Good. Everything is here. But now I have a problem. The electricity company, the gas company said that there's a big pipe going somewhere here. Another infrastructure that goes here. And it gives me the pipe layout in DWG. I can just enter it as a block here. In this case, I don't have it, so let me just draw it. So let's assume I'm getting from the pipe gas company a pipe. And the layout of the pipe, I got it as a DWG, is going from here is going from it's coming somewhere from here, crossing this, and connect. This is the pipe, a gas pipe. Okay. It's a gas pipe. Okay. It's a gas pipe going like this. And it's intersecting my pipes here, here, and here. So the issue now, the subject that I'm showing you now is how to deal with crossing infrastructures, utilities that interfere. Now, if I got this pipe in 3D, it would be perfect. But let's assume that the gas company doesn't have it in 3D. It just gave it to me in 2D. And it says, look, sir, for your own design purposes, just know that there's a pipe going here, here in 2-meter depth. This is the information that I have. How do I do it? I will start with the first pipe which I designed, this drainage. Sorry, not this one. This is the first one. This one. I'm going into pipeline sections. Sorry, of course. Pipelines, crossings. I'm going into pipelines, crossings. And in the pipeline crossings, for now, I see only one crossing, which is this one, right? The one pipelines that we show it. So crossing of other infrastructures. In this case, this is the only infrastructure that I know. This is the, but now there's another one, which is the pipe, the gas pipe. So what I'm doing in the crossing, I'm pressing the filter button here. Just to remind you, we learned already about this filter button when we want to scan points, we want to scan break lines. So I'm doing the same here. Scan. Okay, ask me, which layer do you want to scan? I can just select it from the list, or if I want, I can press select here, go to the drawing, pick the pipe and press enter, and it shows it's a gas and it's a lightweight polyline. This is what it's gonna filter. So first of all, I tell the software which layer to filter and what is the type of entity which I want to filter. And then I press apply. See what happened. The software found 2 intersections. One after 329 meter, which is this one, and another one after 705 meter here. It's a type of gas. We know it's the layer. And the software could not find the invert level because it's 2D. If it was 3D, then the software find the invert level, but there's no. So what I can do, but I know from the gas company that it's in the ground, 2 meter in the ground. If I click here on the top, you see it says invert level. I press here. Again, from here, here. I'm going here and I tell the software, this is 2 meter here, and this is 2 meter here. By the way, the empty lines does not do anything. I can remove them. If not, the software will remove it for me. It happened because I pressed enter. And also, I know that the pipe diameter is 20 cm. For here and here, 20 cm. So again, the gas company gave me the layout of the pipe. It gave me the depth of the pipe. It says 2 meter. This is take it by default because we don't know. We don't have it in 3D. We don't know the exact. And the diameter is 20 cm. Now the layer, of course, and the station was extracted from the layout. If I go now to the sections, see what I get? Sorry, let me remove this. This is coming from the here. See what happened. 1 gas, see, 2 meters in the ground. This is the invert level, this is the running, and the same gas here. So here I don't have a problem, unless there is a specific regulation that says that this has to be a minimum of something. So it also shows the distance to the nearest manhole. But here I already, oh, this is a perfect example because I have a problem here. Now, there's a method to tell the software to rectify it automatically, but I don't like this method because the software might take wrong decisions. So I prefer to fix it by myself. And how do I do it? I do the design. There are many ways how to do it. Maybe create a drop here. Let's create a drop here of, okay, what's the distance here? This is inside. It's a 20 cm, so if I drop half a meter, it will be enough. So this is the station. This is station 301. No, the drop is not good here. I have to create it. No, I cannot create the drop. Drop will not help me unless I'm going above the pipe. Let's do half a meter above, but then it reflects all of this. No, it's not good. Okay, what I'll do, I will change this slope. I will change this slope to be 4%. Then this will be calculated to this point. Now, not to affect this, I have to do something, because if I change this 4%, all this, the rest of the pipe will go down. But here I'm happy, I don't want to change. So I'm going to options, and I'm telling the software and keep fixed invert level. And I'm telling the software goes here, go here. And from this 1.1, this is 1%. Then it's the 5%. Instead of 5%, go by 4%. When I went by 4%, I went below the section. So this is the solution which I found. And if I go to the layout and reproject, software will recalculate. Okay, well, a lot of changes, so it takes the software a little bit. It realign everything, the roads with the layout. It might take a few seconds. Guys, any question? Because we are about to finish. I want to show you some things about reports, and that's it. And then we close this lesson. So anyone, if you have any question, this is the time. Feel free, you can speak up, you can write, because we're about to close the lesson. Just to show you some issues about reports, and that's it. Any questions? None. Okay.
I have a question. Good morning.
Good morning.
Please, I'm Chalia from Gilmore.
Okay.
How can we create like a sand trap that will be connected into the pipeline?
A what? Sorry.
Like a sand trap coming from a plot
Ah.
to your pipeline.
Okay. You created a. Okay. So you say there are connections from here, for
Yes,
sewage,
like
for
from-
example.
Yes.
For sewage,
Yes,
usually.
mostly for sewages, yes. So we can also have sand trap for storm.
Okay. What do you mean by central? Maybe I'm missing the word here.
It seems like plot connection, like you have plot connection for sewage
Okay.
that
okay.
goes into the main pipeline.
Okay.
So
Okay. I see.
how can we do that?
Okay, let's do it together. So the question is to create a drainage pipeline, sorry, a sewage pipeline with connection from plots, right? I will do it quickly now. Just try to follow. First of all, let me save the project. And now I'm going into pipelines list. I created, I will call it 1S. It will be sewage. And this would be the main pipeline here, and connectors. Connectors, I have to define by them by the connection. Let's say, start numbering. Plot, let's say plot number P1, P5 to 1S. Another P6 to 1S. P7 to 1S. All of this are sewage, right? And let me quickly, okay, do the sewage pipeline. Let's say it goes like this, okay? Just for example. Polyline, not that, arrange it. I'll call it my sewage. My sewage. And I'm starting here. Here. You know what? Just for the use case, I'll do a straight line from here to here. I'm sure it would be enough to demonstrate. 40 meter, 40 meter, 40 meter, 40 meter, 40 meter, 40 meter, 40 meter. Okay. This is a pipeline with a vertex each 40 meter. And it sits in my sewage. No, it doesn't sit in my, I didn't make it the current. Not so important, it's just for me to ensure that I'm working in an organized manner. Good. And now, this is my pipe. And I have other pipes that goes, for example, from here. Okay, here it is. From here, one goes like this. And another one goes like this. Okay, so this is the use case. I'm going into pipes, layout. Go to the main one, 1S. This one. And give it a diameter of, okay, you know what? I will walk in millimeter here. Sorry. Okay, sewage is in millimeter. It's easier for me, it's not so important. And I'm saying to myself, this diameter, this pipe from here to here is, let's say it's 400. Huh? Oh, it's not entering. From top to down. Okay, 400. And the manhole diameter I will choose later on. Tell the software to choose it by itself. Okay, so this is 400. And I have P5. Let's say this is plot 5 and this is plot 6. So this is plot 5. And this is plot 6. And if I'm going to the first one, the main one, sorry, 1S, going back to its section. Apply, go to design, get D, apply, okay. And I want to design it. So I start with a depth of 1.5 meter. From here, go at 2%. So 2%. I did a drop, sorry. Depth 1.5 meter. Okay, and then 2%. Now it software will know how to react. Okay. Okay, this is how I start. And here, let's go up by 5%. Yeah. Like this. And from here, continue at 2%. Oh, great. So let me correct it. 0.5. I can see the ground. See it here, the slope of the ground. 0.5. It's exactly what I want. Okay. So this is my pipe. And this is where I have two connections. You see, this connection and this connection. By the way, let's calculate the diameter, size. Okay, so to calculate the diameter for the manholes for me. Now I'll go to P5. Okay, so this is the connection. Okay, see there are two connections here. The main one and the other one, which comes from the second plot. First of all, let me get the design as well here. Okay, so this is in the ground and this is inside the road. And I'm starting, I can start in the exact depth of the pipe, or I can put a drop here, whichever I want. So for example, if this is invert level 63.32, I can start with the same 63.32, or if there's a drop here, let's say 1 meter, 32. And I'm entering with a slope of, the ground is, this road is a crazy road. And let's say, okay, from the plot, let's go by 1%. Here it is. Now forget about the proportion. We know when we take it out, it will be okay. So this is the software, what the software did. It's connect to here, and the diameter, let's say it's 200. Normal size calculate like this. Okay. Now, but we want the, okay, it's my mistake because we're starting with the invert level of this pi. It's 63.32. Right? Okay, we're starting in the same, but now I want to create here a drop. So I do a drop of 1 meter. And this one, okay. You see? This is what I did. I connect from here into here, and since the drop is, it did an external drop as well to break the energy. I hope it's answer your question, and then of course I can go to the next one and continue. P6. So this is the way how you do it. And the software gives you even simulation where there is a pipe going from here out. So again, I'm starting with the same invert level, and if I want to connect at a higher point, I just do a drop here. I hope it answers your question. You have to practice, and if you have a problem, just go to our support. We are already late. Guys, thank you very much for your time. I enjoyed it. I hope you learned. And of course, we are here for additional questions in case you have one. So enjoy the rest of the day. Cheers. Bye-bye. Thank you, everybody.